All right, guys. This Trek into DIY Tech is going to be a project that I've been meaning to do for a while. So back in the day, I used to use GEONadir to process data sets from the drones to do mapping. Now, if you don't know what GEONadir is, I'm going to put a link in the description so you guys can check it out. It's a pretty cool mapping service. It's developed a lot since I initially started using it. And back then, I was using a commercial off-the-shelf drone to take the images for the data sets. So now the thing is, I don't have that drone anymore, and we've been using the ZD550, which you guys can recognize if you've been watching the channel. This is the drone that we use to learn about drones. It's a cinematic drone. It's not really optimized for taking overhead images, but you can't do that with it. But what we're going to do is we're going to switch from that. I'm going to show you how beginning to end the design of a purpose-built drone for mapping. And we're also going to throw in, this is an off-the-shelf action camera. It says 4K on it. I don't know I don't know if the capabilities are sufficient for doing work on GEONadir, but we're going to find out. So we're going to take that camera, and we're going to repurpose this design. So this is a previous design that I have, but we're going to go ahead and repurpose this design here. We're going to add the retractable landing gear. So this is already assembled. We're going to break this up into several videos. We're going to start with the CAD design. Next video is going to be the assembly of the 3D printed parts, and then we're going to go into another video which will do all of the testing, and we'll see what the first data set looks like. But here we are. We started with this. We've done some CAD, and as always, you have this is the dry fit frame. So these aren't so it looks like it's together already, but these are parts that were 3D printed just to test the fit and to see if any adjustments have to be made. And you can see there's a crack there. That's because the sockets for the booms, I made them a little bit undersized. So here we have another 3 prints. And what that is after everything fit nicely on the boom socket side, I added this is the FPV camera, and then we have serial port, USB port, and the power. So there you go. That took, and part of printing 4 of these was we're using a new material. So it's a fast PLA, they call it, but it took about 4 prints to dial that one in. The top only took one go at it, and the bottom took 2 goes, and I'll show you why that is in the CAD. So let's go to the CAD, and we'll take a look at how all of this got designed. All right, so here we are. There's the whole model there. What I'm going to do before we get started, nobody has sent us any of these things, so we're not sponsored by anything, by any company. Everything that we're showing you here, we've sourced ourselves with our own funding. So this is not a commercial for any of these items that you're going to see here, including the software. So this is Solidworks Pro, and I use it and there's a premium version. There's also a maker version. So I have a license to each one of those. So if you're going to do designing for hobby purposes, then you can pick up the maker license. As of this video, I think the last time I renewed it, it was like $49 for the year for the license for the year. Single seat, each one of these. I'm not going to tell you how much the one for work is, but it's way more than that. But in either case, it is very
I'm going to say it's worth it. It's well worth it for me. I've been using SolidWorks for a while, and it works very nicely for me. So I'm gonna continue using it. Um, so we're gonna look at the model here. This is the almost complete model. We have the fasteners out of here. My computer is not the fastest one in the world, so subtracting the fasteners speeds up the animation of the model pretty much. So you can see here where the action camera is. So we have the action camera right here. We've got the battery set a little uh, off center here. It's back from the front to kind of balance out where the camera is. Now the case is probably the heaviest thing on this thing. So that camera case, I'm for simplicity's sake, I'm using the waterproof camera case that is for, and you guys, if you've used the earlier GoPros, you will recognize this case. So we're using that off the shelf waterproof case. And what happens with that, as I change the camera, the weight of the camera is not going to change that much. It's going to be a small percentage of that whole camera assembly. So it's going to keep my center of gravity in the same place basically. So what I'm going to do here, I'm going to remove, or I'm going to disappear all of the props. So we're going to take care of those real quick here, so you can get a better picture of what we've got going on there. So we're going to hide those components. Back with you, back with you. All right, so here we are. You can see a really clear view of this, and you can see we've got this is a DB15 or DB9. They both share the same size. So as we've got those sitting in there, as we've got those sitting in that space, uh, either one will fit in there. So so that's a very convenient thing. So if I want to simplify things and just use the DB9, depends on how many signals I wind up putting through there for the payload. And you can see here the we're using USB-C. I know. But I can put that in either way, because on the inside got we've got a micro USB, so we can use both sides of that USB-C. As some of you know, USB-C is just doubled up, and that's how they get the higher speeds in there. Let's lift up the cover, the top cover, and look inside. So the reason that I get this detailed with everything, it minimizes how many times I have to reprint all of the plastic, because when you're looking in there, you can see some of the tolerances are pretty tight for everything. So I've got the flight controller board is right up against the co-pilot there. And so I'm sorry, I don't have my 3D mouse connected right now. So I'm doing all of this. You can see here the FPV. Here's our FPV camera. And I have a bracket here, and the reason I've made a bracket for these, so I have these two brackets sitting in here, and I'll be able to go ahead and change those out as I change the camera. So right behind the camera, I have some space for the VTX. Our video transmitter can fit right there, right next to the co-pilot, so the co-pilot can have some control over the VTX. We have our ESCs are sitting off to the sides. In the future, we're going to add some venting here. So this side, right on the side there, we're going to have some venting so that we can bring some air in and circulate the air through here as we're flying. We're going to start with passive cooling at first, and if passive cooling, if we go to the 30 amp, right now we're using 20 amp ESCs in there. So it looks like those are more than enough to carry this whole thing, because we're pretty light right now in terms of the overall weight. So later on, if we add more payload, things like that, we upgrade the ESCs. We'll just we'll just change out this fuselage section. So the thing about this is I've created different sections for the fuselage. So you have the bottom. So you have the bottom section. The bottom section is in there, and then we have the fuselage section, the center section. And the reason for that is, so say we have some damage, I make some updates. I don't want to have to reprint the whole thing, right? So I can reprint this. I can reprint this in sections, and we have 3 separate sections that we can go ahead and reprint by themselves. So we have the bottom section, we have the mid section here, and then we have the top section where the antennae and antennae, like it's a bug. The antennas sit up there. We can reprint each one of those individually. So now the thing that you want to do when you're creating things like this, there's a lot of considerations in there. So you see how the landing gear go right into the bottom section of this fuselage. So it goes right into there, and also you have the battery screws are right into there as well. So I'm going to show you on the inside. You can see I have these rib features in there. So important thing, we have ribs in there to stiffen this up, but we also made the ribs small enough, or short enough, and the width is just enough width to get that stiffness, but without adding weight. So anytime you add weight to a drone, that's flight time. And we're going to use this for mapping, so we want to maximize our flight time on that battery. So if we're adding weight, we have to be careful to we're adding just enough to do the job, but conserving that weight. So the thing for this one is, so we have these ribs in here, and like I mentioned, the screws for the battery. So the ribs are providing support for the screws for that battery, and also the tolerance for getting the landing gear in there. So this landing gear is going to want to do this when you land, right? Because there's a big skid under there, and as you're landing, there's going to be a lot of, so making this wall slightly thicker where that depression or that pocket is for the landing gear. And also you can see the tolerance on that's pretty tight. So that's why there were 2 prints on this, to get that exactly right, so that when I put the screws in there, part of that stress is being handled also by the sides. The other thing that we have in there is, so a lot of considerations, right, when you're doing this. So there's this cable. What do we do with this cable and this connector? So this is a servo in here. We need to get that cable in there. So there's the hole to get the cable in there, and then there's also a nice channel for that wire to go in there. And so the hole's just big enough to fit that connector, and then when all of this goes together, that wire is just going to go right across the top there and down that channel. So, and I'll fit this nicely so you guys can actually see. So you see that wire goes right into that channel, comes right out there. So just some of the considerations that we have when creating the models. And I'll show you that real quick on the model. And there you see we've already fitted the carrier for the Arduino Nano that's going to sit in there. It might be a Nano Every. They both fit in that same. So now, as we're going through this, I'm going to show you real quick the inspiration for this. It's the red snapper, because the next parts that I'm going to show you, it's going to be relevant to that. So we're going to take a look at the red snapper, the fish, real quick. So All right, we'll put that up in the corner here for a second. So now you can see what we're working on. So I do have I don't know if you can see, there's two shades of red. Let me know in the comments which shade of red you think best matches that picture, the reference picture. So I always keep that reference picture around so I remember what I'm doing. But as you can see, even in the color of the plastic, it's kind of interesting to see how everything comes together. Now I'm going to show you another thing. Aside from the ribs in the top and the bottom pieces, you can see there's a little bit of twist in here, which right, that's no good for the booms are going right into here. The motor arms are going right into here. So if this has any sort of twist, this thing is not going to fly. So now I'm going to show you when these two come together. So there's a feature there for right on the edge to line that up. And so as we put these together, now you can see it's already started to stiffen that up a bit. So I'm applying about the same amount of force, and now it's starting to stiffen up. But the whole thing comes together when you now attach the top to it, and now I'm even applying more force to that, and you can see that that structure has stiffened up. We don't even have the screws in here yet. So that's one of the things that when you're designing something like this, and you can see the ribs in there, and it goes through where the GPS. So the GPS mounts are up at the top here. So you can see those screw bosses there, and we're bringing the ribs through there as well. So that section, you can see how flimsy it still is with those ribs. But then once everything gets screwed together, it completes that structure, and all of those forces are tied together almost in a circular manner so that there's no flex there. And so we can see we'll make these transparent for you so that you can see what it looks like in there. All right, so there you see how all those components are nestled in there. But anyway, that's pretty much it. So again, important parts, creating the design, having these, having everything modeled that way, you can get a pretty good idea of how to lay it out. And furthermore, if you have the simulation software, which can get very expensive, there's some open source versions of simulation software out there that you can use, but you can get the center of gravity worked out. All of those things can be worked out in the CAD model before you even start printing any of these things. And so there you go. Next thing we're going to do, we're going to go to the assembly of it in the next video, and then we're also going to go to the loading up of the firmware, configuring everything, and then taking that test flight in the third video. If we do some, not if we do some mapping, we're going to do some mapping. When we do that, I'll show you how to set up the mission in Q ground control. We're going to use Q ground control, set up the mission. We're going to take the images for the data set, and then I'll show you how to load that up into GEONadir after that, and see how that's processed and what you get out of it when you finish that.
All right, so I hope that gives you a good idea of what the scope is for this project. So one of the other things that we're going to do as we go along, and maybe it's this will be another breakout video as well. This is the trigger for the action camera. So instead of breaking into the case and running wires in there and doing one of those interfaces, I'm going to show you how we're going to go into here. We're going to put a connector on here, and then we're going to connect this up to the flight controller so that the flight controller can actually take control of snapping the pictures. So we're not just going to set up the camera on a time lapse and let it snap pictures that way. We're actually going to set it up in Qt Ground Control, because Qt Ground Control also has the facility with PX4 to give you control over the camera. So we're actually going to go the whole way and set the camera up so that we can control where the images are being taken from. So stick around. It's gonna be a good one. We're gonna go deep on this one. Red snapper, go deep in the water. Never mind. Hey, as always, I appreciate the time you spend with me. We'll see you in the next video.